All right, guys, today we're going to look at the property of insolation, okay, where we're going to measure how much light we have on a given area. So, of course, we'll have this lab posted for you to look at, but the light from the sun strikes the earth at different angles, and we want to study that. So what we've done is we've taken a light and we have shined the beam on a piece of paper and we've traced that beam, okay? So here's an example of what we ended up in class. So when the light was 90 degrees above, it made this area, and then 60 degrees, it made this shape, and then finally 30 degrees. So we want to count the boxes in each of these to collect data for our area. All right, so on your lab paper, you're going to have 90 degrees down here at the bottom, 60 degrees, and 30 degrees, okay? And so for our first light, we had 42 boxes, and then we had 46 in our 60 box and 55 in our third box for the 30 degrees. To get the strength of light following the paper's data, we're going to take 200 divided by 42, and that'll give us our strength. All right, we repeat that by 46. And 200 divided by 55 equals 3.6. So you want to be able to recreate this. So take a moment now to collect this data. Okay, guys. So at this point, let's talk about this. Okay, so this is important for all of us to understand. Heads up right here. Okay, tune in. Did you change the amount of light? And the answer to that is no. We had the same amount of light. Please add this to your notes. All right. We had the same amount of light in every case. We didn't turn our flashlights from brighter to dimmer. So we had the same amount of light. But when the light is at an angle, what happens to the area? So what's our data doing right here? The area is increasing, right? The area of the light increases. So now, do you have more light? Again, no. You have the same amount of light over a larger area. So what are these numbers telling us? These numbers are telling us that you have less light per area. So these numbers are going down. They're decreasing, which means you got less light per area. And what we're talking about in area is less light in an ecosystem, okay? So, now you have to be careful about the way this data is created, because 90 degrees is not 90 degrees on the globe. So we have to be careful here. 90 degrees represents the equator for this experiment, but the equator actually measures 0 degrees on the globe. And 30 degrees represents the North Pole, if you will, which is actually not 0 degrees, is somewhere closer to or not 30 degrees, but somewhere closer to 90 degrees. So what do we find at the equator? That the equator has a smaller area for the sunlight, which means that the ecosystem of the equator is going to have more light. So what's going to happen to the temperature there? Going to be a higher temperature. Okay? All right, so there are some questions for you to answer about this data. This is a property called insolation. Okay?